Hey everybody, Lars here. Um, it's Saturday, February 27th, and I was thinking to myself, I know I said when I did the second video for this unit that I was going to do FizzBuzz and the rainfall problem and blah blah blah, but I thought it was probably more important to get done with the review videos for Unit 3. That way you'll have all the videos for a week, 8 days, and you'll be able to use them to work on your assignments and get used to working with modularity. It's a really long unit, and I figure it's more important. And I don't want you watching the videos on previous assignments during the last week of a unit anyway. So I'll do them in good time and probably release them like around spring break. You probably noticed that Unit 4 encompasses spring break, but I let you take that week off. So time-wise, Unit 4 is 3 weeks, but it's really only 2 weeks that I expect you to be working, and there's 2 weeks of content in there because it's spring break. I figure you should have it off. I know I'm taking it off, so you should take it off too. Um, so I'm going to do the video on modularity tonight, which is really, hopefully, and I know I say it all the time, that we're going to go quickly, and I'm going to hopefully get you out of here fast, but I don't know because I definitely want you to see it, and I definitely think it's fun and interesting. And this is the video you want to watch if you want an insight as to how to go about getting done what you need to get done for assignment number 2, which I released today. Assignment number 2 is out there for you to see, and it basically involves you creating a library of your own. In this library is going to be your hardchat function that you wrote, but there's also going to be another function, and then you're going to use those functions from your library in another main program where you're going to read in a list of random numbers. And you'll see as I go along tonight that we're going to do all that stuff. But at first, as you can see in front of us, I set up a quick little program for us to tinker around with. And just to get us started, let me just do this. Print some my list, yeah. When you run it, you get 958. I'm assuming that's correct. The reason I do this is because sum, right here, and we discussed it a couple videos ago, is a built-in function. It is there and ready for you to use, okay? But what if I wanted to find out, let's say, the square root of a number, and I wanted to use a function called square root. There is actually one called square root, and say I wanted to find out what the square root of 25 is. So let's print it. Uh-oh, doesn't exist. Square root is not defined. Now, I know there is a function called square root, but it resides in a library, and that library, actually, I should go bring that up. I need to get prepared. But it's good you see this process too, because you can see how we search. Python docs standard library. I have a funny feeling we're going to be all right. All right, I'm going to go to 3.5, obviously. And boom, you can get 3.4 if you want to right here, but 3.5 is 5. Python comes with, and it's actually installed on your hard drive when you load Python from python.org, a thing called the standard library, okay? The standard library is full of, and you can see them here, different libraries for you to use to write your programs with. The problem is, not really a problem, but if you were to load all of these functions, Python would be unwieldy and so big in memory that it would be difficult to use. So what Python does, and what C did before it, is put all of this code in different libraries that you have to tell Python you want to use. So it's all there for you. It's installed on the drive and on a hard disk, but it's not all put into RAM like sum is and just sitting there waiting to be used. You have to tell Python, hey, go to the hard drive and load this library for me because I intend to use some of these functions and some of these classes and different things. You'll see if we come down here, you see the math library. I'm going to tinker with the math library. And you can look it up and you can see there's ceiling. Now, if I come down here, I think I will find my guy, square root. Okay, that's what I was talking about right there. So how do we go about using the math library? It's really simple. Watch this. I am going to, now usually it's the first thing you do. I'm going to import the library. So I say, my first line of code, import math. If you're a C programmer, think include statements. You always did your include statements at the beginning. Well, yeah, I usually do my imports with Python at the beginning. So now, as easy as that, I've imported the math library, but I still have to tell square root where to go to get it. You see that idle will come up and show you all of the available functions for the math library. So I write math there and I say dot square root and I say 25. Let's go see if this works. And you can see it does. 5 is the square root of 25. So now I'm able to use the square root function. Okay. You can also, I could just use one line. Use other libraries. I'm just load the statistics library. I will say print statistics.mean my list, and voila, we will print the mean of my list up there, which is 59.87. So that's slightly sloppy. Let me do this instead. Let me say A equals statistics mean.list. Then I will print A. Then I will say B equals math dot seal. I said I before E, except after C. Seal A, print B. Right, let's see what we get here. And I hit F4 again and brought up the document. I should have done that before and not even bothered with the web. F5. Invalid syntax. Oh no, what have I done? What have I done? I don't need that last paren. There we go. All right. Excellent. What I've done here is I've gone to the math library and I got the square root of 25 and I printed out a 5. Then I have made the variable A equal to the mean of my list. I went and got it from the statistics library. And I printed A, and the mean is 59.875. Then I made the variable B equal to the ceiling function of A. The ceiling function just rounds up. That's all it does. As a matter of fact, there's another one called floor, which rounds down. And we can do that here. Do I C equals math dot floor A. And then down here, I'll just print it right there. All right, so now we have both. Okay. So I print the mean, and then I can print the ceiling, and I can print the floor. All right. One more thing that I want to make you aware of here is that I usually use just import and then write out the library because I want to know where I'm getting my particular functions from. Okay. But there's another way we can do it. I can say, let me put that down there for a second. Instead of import math, I can say from math import and then tell it the functions I want. Okay? And then, well, there's another trick. From statistics import mean. Now, because I've done it this way, and I've said from this library import square root, ceiling, and floor, and from statistics import mean, this basically maps where those functions are being called from. So I am not going to need the library in front of the function anymore. So actually, you'll see I can do this. Oops, I'll fix that in a sec. Okay. And as you can see, we get exactly the same results. I've just imported in a different fashion. Basically, this said go to the math library and just get the square root, ceiling, and the floor functions. And when I use them, this basically up here is going to say I'm getting them from math. Okay. Now, the reason I like the other way is because we have a very small what's called a toy program here to learn from. When you get into programming and you become a professional programmer, programs get a lot bigger. I mean, I remember when I was a kid and they said programs got bigger, and I said, they must be millions of lines and this and that and that. They really aren't. When programs are broken down and compartmentalized so that each piece of code does a certain little thing, sometimes you get maybe 500, 1,000 lines of code. Some really big programs can be like, 5,000 lines of code. But usually you don't find, unless you're an operating system and you add up all the programs together in the system, you'll never have something that's a million lines of code. But you could get a big program and be deep in the program, and all of a sudden there's a function call. And if it's from a library, I, as a programmer, would want to know that. So if I did from import at the top, and then I just used it by the function name, I don't know that. I don't know if it's coming from a library then, After a while you do, because you kind of know what the standard library has and what it doesn't. And standard naming conventions versus funky variable names. So when you see a funky variable name, it's somebody's home-written code. But I like the old-fashioned way. But I want you to see this, because a lot of people do use this. A lot of people do things this way. They don't want to be bothered by putting the library first. So a lot of people will do things that way. All right? That's how we import and use functions from the standard library. And I beg you to go to the standard library and look at everything that's available, because it's incredible. Anything common sense that you can think of to do with your programs, it's probably been done already, and there's a bunch of standard library functions to help you do it. Okay? Dealing with the internet, dealing with HTML, dealing with communications, dealing with email, dealing with making windows and GUIs. GUIs are graphical user interfaces. Doing math, doing even more complicated math. There's an incredible amount of stuff. And you can learn so much by just, when I was a student, I would just pop something like this up, and boom, I would just go, hey, numeric types, and I would just start reading. And that's where you really learn about languages, when you start reading this kind of stuff. And then iteration tools, a really big plus if you want to work on a lot of the Project Euler stuff. So iteration tools comes in incredibly helpful. File input, not the simple stuff we did in our last video, but some more stuff there. os.path has a lot of things that help you write scripting programs for operating systems. There's a lot of stuff here. Python is incredibly well supported as far as having a standard library and having a lot of third-party code written for it. So be aware of that. Now, the big guns. This is called Scratch UV RV3.py, and of course I'm going to put it up in Sakai for you to see. But what I really want to do with this video is have a little bit of fun doing a homework assignment of my very own. It won't be your homework assignment, but it'll be close. So, let's say this is my homework assignment. Let's say I've been told I have to take a list of 500 random numbers, and I have to search through that list, finding the palindromes in that list. If you don't know, a palindrome is something that reads the same forwards as it does backwards. Think race car. And I know there are other super long ones, but I don't remember. Race car is the one I always remember. Okay, but like your assignment too, I can't just do it in one program. I have to create a library. And that library has to contain a function, a constant variable, and then I have to have a main program that reads in 500 random numbers and determines which ones are palindromes or not, okay? So that is my homework assignment. What am I going to do? First thing I think I'm going to do is go grab those random numbers. So watch this. This is kind of neat. I always like this site. Google random, and there I get it already. Random number generator. Am I going to go to the right place? Actually, don't I want to go to rand? Random.org. If you intend to become a computer science instructor in the future, random.org will be your friend. Because random.org is where you can come to get the random numbers. You'll see I come up here, I go to numbers, I go to integers, and I'm going to generate 500 integers. I'm going to make them bigger than 100. I'm going to make them up to 10,000. And format in 5 columns is 5. And then I say go get the numbers. And look at that. It goes and grabs those numbers from me. Now, what am I going to do? I'm going to highlight it. Pretty good chunk of numbers. Make sure I go down to the end. I'm going to copy, and then I am going to go into Notepad. I'm going to paste. Look at that. I maintain my columns, which of course I do. Tab, 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 new line. And I'm going to save. Save as. I actually set up a directory for this. And I'm going to call it my randomnums.txt. Randomnums.txt. And I will upload this exact same file for you. So rnums.txt is the name of my file. So, and that, as simple as that, is how you can go grab random numbers, as many as you want, as many columns as you want, and put them in files and play with them if you are doing things with Python. All right. Now, what do I want to do? I want to get a new file. And this is going to be my library, but we're still going to comment it. Oh, I want to do that. Because commenting a library is just as important as commenting a regular program, because people will come in here and read it. So this is still a comment. Wars. And I will call this a palindrome library. All right, what do I want? I want a function that takes a string as an input and returns true if the input is a palindrome and false if it is not. So I will call it ispalindrome. I will take a string and I will call that string the string. There's got to be something. I will call it ppal, potential pal. How's that? Potential palindrome will be the name of my string. All right. Now, the reason I pick palindrome for a reason, because it's pretty easy in Python. Python has a little trick that we can do with strings, and we can basically determine if something has a palindrome in one line. And the way we're going to do that is we're going to say if ppal equals ppal, but we're going to slice it. And we're going to say from beginning to end, but we're going to go backwards. Okay? So, if ppal, the string, is equivalent to the string printed backwards, that's a little trick that we do when we can splice into our string, we can print it backwards. If they're the same, that's the definition of a palindrome. So if those two things are equal, I return true, else return false. All right? Now, that is begging to be tested out. So even though I'm sitting with a library right now, let's see, A equals is palindrome. You know what? Enough of this is palindrome. Is pal will work just fine. Thank you very much. Make our lives a little bit easier. Is pal race car. And then print A. Now, if the palindrome gods are with us, that will be true. This is going to ask me to save. And I will go up and I will say Python Data Science 2006 U3 video. And I'm going to call this tools.py. It's already got the py for this. Okay, so this is tools.py. That's going to be important later. You're going to say, let's run it. Say, what we got now? Yay, it says true. Now, let's mess it up so that it's not true. So we make sure now it doesn't work. And now it says false. So we're in good shape, I think. Let's double check. Let's say 323. Hello? There we go. True. I like it. But now let's put a bunch of 7s in there and mess it up. And now it says false. All right, I think our IsPal works. I like it. But we are writing a library, so we don't want any code in there. We need to do one more thing. We need to define a constant variable. So I'm going to type Seaver as the variable equals 41. Okay, that's simple. Just define a variable in the library. Save it, and then you know what? Done. So I now have a library with a palindrome function. I defined a constant in there because because that's what you're going to have to do. So I figured I'd do one real quick just for you. And now I need to write a main program. Let's see, new file. Let's see about doing this. This is a comment. Read in 500 random numbers and see if they are palindromes. All right, we're in business. Now, we want to read in that random number file, and then we want to use our library, or the function in our library, to see if any of those random numbers are palindromes. And if they are, we'll just print them. We're not going to throw them to an output file. I'm going to leave that for you. And we deal with output files in the previous video, so you should be good with knowing how to do that. So what's the first thing I'm going to do? Well, I'm importing from a library, so I usually take care of that business first. And I'm going to say import tools. Done. We're doing it my way. I'm not going to do the from tools import IsPal and Seaver. We're going to do import tools, and then I'm going to put the library in front of it when I use it. So what's the next thing I want to do? I want to read from rnums. So I am going to say in file equals rnums.txt. So I have the file name set into a variable. Then I'm going to call my file object f. And I'm going to say f equals open in file. And I'll be opening this in file for reading. Then I'm going to say data equals f.read. And that's going to read my data. And we all know I'm a good citizen when it comes to file I/O. So I'm going to close. And that's simply, boom. We now have data, a string populated with all 500 of our random numbers. But they also bring about all the gobbledygook. You know what? I'm going to show you what I mean when I say gobbledygook. This is going to want me to save it. So what am I going to do? I'm going to come down here to Data Science 2006 UV video. Here's my tools library. What am I going to call this? I'll call it UsePal. There we go. And when I run UsePal, there's my file. Nice and easy, right? So now I have those random numbers. You just saw me not 5 minutes ago. I went and collected them from random.org, stuck them in a text file, and now I'm reading them into a Python program where we're going to use them. Now, we're Python programmers, okay? We're not just regular Joes looking at Windows stuff. Not just regular Joes reading Facebook, playing the lottery, playing scratch-offs. What we are is programmers. So we don't see 5 columns here. We see number, tab, number, tab, number, tab, number, tab, new line, okay? So the goal now is to get this data in a format where I can iterate over it. Because if I can iterate over it, then I can consider every one of those numbers to see if they're palindromes or not. Ooh, do I see any? I would not want the job of having to eyeball this. And I do not see any off the top of my head. Oh, baby, nope. All right. Up. Look at that. Those eyes are good. All right. So we have at least one. 3113 is a palindrome. That should pop up pretty quick. But I need to do it with my program. I can't sit here. That's why we have programs. So I don't have to sit here and eyeball all that data. The first thing I want to do is I'm going to say data. Well, first thing I'm going to do is write a comment. Because I want people to know what I'm doing. I'm going to clean my data. And the first thing I'm going to do is I'm going to say data equals data dot replace, and I'm going to replace all of the backslash n's, watch this, with backslash t's. Okay? I'll explain that in a moment. So once I do that, I'm fixing to use the tab as a delimiter. It's in between every number, right? So I figured that would be a smart thing, but there's a problem. I got tab, 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 tab. When I get here, I got backslash n. So if I did a split and I use the tab as the delimiter, well, this is going to mess up because I got 4236, new line 4298. That's all going to look like one big number if I do a split with the tab as the delimiter. So what I have to do is make sure my delimiter is the same throughout the entire file, and I could do that by just changing the new lines to tabs. All right? So, and I'll show you right now. Look at this. When I print the data, see how it goes across the screen now? There's no new lines. The only reason they're dropping to a new line is because that's the way idle prints them out on the screen. Okay? If I could stretch this window, a mile across, there would be no new lines. It would be a sequential line. So right now, the only thing separating these numbers are tabs. All right? And that is good if you're a data scientist and you want to clean your data, because then the very next thing we're going to do is say data equals data dot split, and as our delimiter, you guessed it, the tab. Okay? I don't even have to mess with that print data. So now that we've done this, now I have a list. Look at that. You can see my bracket down here at the end. I'm not going to go up and grab it. But now we have a list of all the numbers. Now you'll notice they're strings. When you use a string, you're busting up a big string and making a whole bunch of little strings that get put into a list. So we're actually in pretty good shape, though, because our isPal function takes a string. And that's what we have. So we're not in bad shape as far as that's concerned. So we're almost there. Now what am I going to do? Now I'm going to use isPal to determine the palindromes. So now I don't need to print data anymore. I will trust my list. So I have data is now a list of all my strings. So what do I want to do? Well, I want to iterate, of course. I'll say for I in data. No need to do any range, any craziness. I'm just going to look at every single thing in my thing, in my list. And I'm going to say if tools.isPal I equals true, then I'm going to print it. And that's it. I should be good right there. Okay? The anticipation is killing me. Let's run this program, see what we get. Ooh, a quick look. Looks like the palindrome program works. There's my 3113. 4 9 3 3 9 7 6 7 5 3 3. I think we're in business. Well, maybe we should count these bad boys. C equals 0. C plus, how about the other way around? Plus equals 1. And then down here, print. There were C, comma, palindromes. All right, there were 15 palindromes. All right. So, do I have my library so I can show the whole tool chain? I do. I know, I never read Enceiver. We're getting there in a second. All right, so I start my program. I had a file of 500 random numbers in 5 columns. So what did I do? I imported my tools library. It's right here. I created it. It's not math or statistics or anything complicated or anything crazy. It's mine. I did it. I'm importing my own library. So then I read the rnum file, which I created right here 10 minutes ago. I open the file for reading. I read the entire file into a string called data, and then I close it. Boom, done. So I don't have to worry about file I/O anymore. All I have to worry about is a big old string called data. File's been opened, read, and closed. Done. All right there. So then I clean the data, and as you saw, I can take that replace and get rid of my new line, so everything is a tab. Everything separating those numbers was a tab. So when you do your assignment, you're going to see Rumbers is 5,000 random numbers, but it's the same thing. I think Rumbers is 10 columns, but it doesn't matter. It's going to be 9 tabs and then a new line. So think here, okay? And then we do the split by the tab, and it loads up a list of the 500 different numbers sitting in a list. Then all we have to do is iterate the list to determine if these numbers are palindromes or not. So I just, grab a blank counter. For I and data, it's a list. I can iterate it through now. And here is where I go and I use my isPal function in my library. And I tell it to go to tools. That's what I created. And I say, hey, is it a palindrome? If it is true, then print it and click the counter. And then at the end, I print out what they were. And it is that simple. Okay? Get a good look at that screen right there. That's going to be very helpful as far as what you need to do for your assignment. Now, part and parcel of what this is all about is I'm just going to go grab a new file right now. All right, I'll fill them in later. And I'm probably just going to call it test.py. And let's just say I want to do some random palindromes. So I say import tools. A equals tools.isPal race car. Okay, did I spell that right? No, I didn't. Race car done. B tools.isPal 112211, which is also 1. Okay, and then I'll say C equals tools isPal tools dot, I call it Seaver, right? Yeah, I told you to do Hodges in your homework. Tools dot Seaver. Then I'm going to print A, comma B, comma C. Okay. What do we get when we run this? Let's save it first, which is always a good idea. Let's bring that. We'll call this. I'll just call this test P, and I run it, and it's let's see. Oh, interesting. It's good we saw this. That's a very confusing error. But isPal race car, fine. isPal, that, fine, because I'm giving it a string. I just gave isPal, which wants a string, an integer, and it freaked out. It gave me this line, and it says int object not subscriptable. So that means it tried to take the integer and superscript it and print it backwards, and it couldn't do it because it's not what's called subscriptable. I can change that. Hold on. That's why the good Lord made casting. There we go. So now I make it a string, I rerun it, and now it works. That was a good error to see because you got to be mindful of your functions and put in the right things. So there you go, true, true, false. Okay? Now just to make sure I'm getting the right thing, let's print tools.Seaver, just so we can see that bad boy stick out. We do, number 41. If you're a Met fan, you know what I'm talking about. So the reason I did this is to show you I didn't do anything with the palindrome. That's my library's written. It's waiting there for me to use. I never have to write a palindrome function again in my life. Got that palindrome problem licked. Never gonna have to worry about it again because it's written and it's right here. And that's what we go for when we program. We set up our own libraries and we try to do what's called code reuse. We want to make sure we're not doing things 2 or 3 times. You know, that palindrome thing is written there. I have it. I can use it anytime I want. Okay. Now, Seaver is more so I can show you how to create a constant, and then we can use it in there. You'll see in the math library they have constants like e and pi, but you can set your own up. And it's convenient because then you only have one place where you want to have to change it. Okay? If I change Seaver here and I make it 123, better yet, I'm going to make it a palindrome so that I get true in the last one. I change Seaver there, right? I save that library. When I come here and I run, they're all true now. And Seaver's been changed, all right? With no change to my main program. So you can do that with constants as well. You can use that constant all through your program, and then here, because it's been defined in a library, you only have to change it in one spot. Okay? But when I say constant, that's all I'm talking about with Python, is defining the variable in a library and then importing it and using it. I know constant has a different connotation in C and in Java and a whole bunch static variables and blah, 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 blah. When I say constant in Python, all I want you to do is define a simple variable in your library and then import it just like you would import a function. And as you'll see in Unit 5, import a class, because you can keep classes in libraries too. All right? So that's basically it. We created a library of our own to do palindromes, and then we showed how it was used. All right? So that's it when it comes to modularity and creating your own libraries. It's that simple. So think about what you've seen tonight in the context of your second assignment. You know, in your library over here, you're going to pop in your harshad function. You're going to have your isCiete function, which is going to look into the second column to see if you have a 7. And then you're going to define that Hodges variable. And then over here in your main program, or in the, the other program that we had up before. Let me bring it up. Just to be complete. Open. Oh, good. It's there. I called it use pal. When you have your file, okay, your program is going to import your library. I think I told you to call it mylib. And then you're going to take in that Rumbers file, clean it up, and then go through it, see what's a harshad. Then after you have a harshad, and you should put it in a list, then you find out how many have a 7 in the second column. Do it again and run them all through isCiete. That's all. It's not hard. It's not, I mean, what was it? We ran, what, half hour, maybe a little more? And we did it all in that right now. Boop, boop, boop. So I just wanted you to, this video is the one that I want you to see before you do the homework assignment. Because if you read that homework assignment and you haven't seen, how this simple process works together, that homework assignment might freak you out, but it shouldn't. And I just need the 3 things. I need you to add up the sum of all the harshad numbers. Then you got to create a file with all the harshad numbers that have 7s. And then at the end, I think you just have to print the harshad 7s that are multiples of Hodges, which is what, 14? If you're a Met fan, you know what that means too. So that's it. Easy peasy, lemon squeezy. All right? All right, this is good. It's Saturday night right now, but I am probably not going to release this to you until tomorrow. If you've looked around, that assignment 2 is out. So you basically have what you're going to get for Unit 3. And now you have a whole week to, number 1, make sure you do that midterm report and you've engaged with all those different 3 resources. And you have that paper ready to go on Friday night. But also next Monday, it's going to be the end of the unit. And that's when you're going to have your quiz, and that's when the 2 assignments are going to be due. But now you have your Zell, you have your slides, and you got 3 review videos for all of the content in Unit 3. And at the end of the day, in only 7 days' time, that's going to be it for Python, basically. I always say the first half of the course is learning Python, okay? The second half of the course is using Python. We're not going to be we're going to learn, and you're going to pick up some new things here and there, but that's true of any language. I learn things still, and I've been doing this nonsense for 30 years. So that's going to be true for the rest of your lives. You have the basics right now, though. You've got data. You've got iteration. You've got sequences. You've got functions. You've got file I/O. You've now got modularity. All right? Unit 5 is going to be important because you're going to learn about object orientation in classes. Nowadays, you do need to know a little something about that Because when you try to use other libraries and other people's code, it's all object-oriented. So without that, you'd be like, all right? But after that, you're going to have what you need to go out and avail yourself of all those Python resources. Matplotlib is a third-party library. It has everything you can do in MATLAB, and it is free. Pygame lets you create and develop 2D video games, okay? And you can make a reasonable Tetris, which I'll show you in class, and you can do other things that are really swift. If you Google Pygame programs and look at some of the things that people do for video games, they're really good-looking, sophisticated, scrolling video games. So there's a lot of things you can do. And basically, the end of this unit is the end of the basics. Unit 4, we're going to look at computer science topics, searching, sorting. We're going to look at analysis algorithms a little bit. We're going to look at recursion. Then the 5th unit is the next big one, kind of like this unit. And there we're going to go over object orientation. And we're going to learn a whole new way to write up our programs. But it's going to make sense to you. And you're going to have a lot of aha moments when you do that. Okay? So you've got it. All right? I'm probably releasing this tomorrow night, so there's not going to be much left of the weekend. So I'm not going to tell you to enjoy your weekend. But get that work done on that midterm, and Unit 3 is closing up. So make sure you engage with all of these resources and begin working on assignment 2, okay? And as usual, if you have questions, go in the forum. Go in the forum and ask the questions. I don't know how to do my homework. Do my homework for me. Nothing like that. Ask specific questions. But if you ask specific questions about doing specific things, Eric and I will be in there, and we're there to help. All right? Good. Then you have a good night, and I will be in touch very soon. Hopefully the next video and the next thing you hear from me might be from Memphis. Although I'm going to wait, I think. Maybe I'll do the videos in Memphis, and then I'll wait until after Unit 3 is over to release them. Because I want you concentrating on this stuff before the assignment, before the quiz, and blah, blah, blah. And then I'll unleash the rainfall and the FizzBuzz videos on you at the beginning of Unit 4. Because like I said, Unit 4 is going to be fun because right in the middle there is spring break. All right? All right. Anyway, I'll prattle on all night if you let me. I'm going to get out of here. You have a good night, and I will talk to you very soon. Bye.